Hello and welcome to the Section 5.1 lecture. Today we're talking about percent increase and decrease. So as we get going here, this will probably take us to the end of our first term material, and we only have a couple weeks left. So hopefully you had a good little break and you're ready to get back at it. And here we go. So it says, how do you use percents to describe change? And then it goes on to say, so we're going to focus first on finding the percent increase. It says percents can be used to describe how much an amount changes. And to find the percent increase, we want to take amount of change over the original amount. This change may be an increase or decrease, but the increase describes how much the quantity increases in comparison to the original amount. Let's go ahead and take a look at this first example. It says Amber got a raise. Awesome. So she's working and she's going to make more money for the hours that she works. Her hourly wage was increased from $8 to $9.50. What is the percent increase? So we need the amount of change in the original amount. We have the original amount, but we don't have the amount it changed yet. So to find the amount of change, we take our bigger value, or our for increase, I kind of hate that they say this, but we take our greater value. I might think of this more as the, instead of greater, I'm going to say later. I'm going to have to look at that. Give me 1 second. Okay, hopefully that's better. So when I say later value, I mean what it changed to, and then lesser value, I gotta think that I just always want to say original amount. Okay, that should always work. I'll let you know when we get to percent decrease if the way that they're setting it up doesn't work. But for now, you can think of it as the greater value minus the lesser value to figure out which one is different. Well, yeah, I can see where maybe that might fall through. But for now, we can go ahead and think either way. So we take $9.50, subtract 8, we get $1.50. So that is the amount of a raise that she got. That is the amount of change. So we take that amount of change and we divide it by our original amount, $8, and we get a decimal, which we should. It's okay. And I totally recommend the use of calculators here. I don't want to take you away from that idea. And so we get a 19%, or roughly 19% of a percent increase. So what does 100% increase mean? If something increases by 100%, well, a 100% increase means to double the original amount. Okay, think about that. If this percentage was 100% and we back that up a little ways, that would mean that the amount of change is equal to the original amount. And if we back that up even farther, that means that the newer or the greater value was twice as big as the original amount. Okay. The price of a pair of shoes increases from $50 to $64. What is the percent increase to the nearest percent? As I stated before, you will want to use a calculator on these. Okay, just to make, I'm not testing whether or not you can divide numbers. And for that matter, I'm not testing whether you can subtract either. But we want to look for our amount of change first. So we'll take our 64 and subtract 52, and we should get 12. Sometimes I even find that it's helpful for me just to check that. Now, the beauty of using a calculator like this that you can't see, is that now that I have that, that's going to be my numerator in my next step. Because now I want to take that amount, and so we're going to say that we have, to find our percent increase, we're going to take our 12 and divide it by our 64. Oops, sorry, 52, not 64, the original amount. Okay, and I don't want you to have to worry about what this is, so use a calculator. Divide it by 52, and we get 23.07. Sorry, 023 point, no, not another decimal, stop it. 07. They want us to round it to the nearest percent. To turn a decimal into a percent, bump the decimal over 2 places, and we get 23%. Okay, let's move on. Percent decrease. Yeah, I guess don't take the original and subtract or don't take the later and subtract the original. That doesn't work out, I guess. Dang it. Because of how they have it. There's a way that you can do it, but don't fall into that trap. David moved, let's read this part, I guess. When the change in an amount decreases, you can use a similar approach to find the percent decrease. It describes how much a quantity decreases in comparison to the original amount. David moved from a house that is 89 miles away from his workplace to a house that's 51 miles away. So he moved closer. What is the percent decrease in the distance from his home to his workplace? So we do want to go greater minus lesser. We want to take the 89 minus 51, and we get 38. And then we want to use that same idea, amount of change over original amount. So 38 divided by 89 is about 0.427. So rounding that, we move the decimal over and we get about 43%. Okay. David considered moving even closer to his workplace. He claims that if he would have done so, the percent decrease would have been more than 100%. If the percent decrease, so then it's saying, is David correct? If the percent decrease is more than 100%, let's just say that, percent decrease more than 100%. First of all, it doesn't really work. That's the biggest thing. For the percent decrease to be 100%, let's think about that. If the percent decrease is 100%, that means that the change, the amount of change is equal to the original amount, just like it was in percent increase. And it would basically mean that he moved to his work. Some people claim that I live at work. Not true, though. I just live very close. So if our percent decrease is more than 100%, that means, well, we're just going to say that isn't possible. Yeah, I'm just going to say that isn't possible. Because if he's trying to say that he used to live here, let's say his old house, and then his work is here, if he's trying to say that he moved this way of his work, but he's closer, right, saying that he moved over 100% of the way, distance has a weird thing that it's always a positive value, okay? Because, yes, he might have moved past his work, but he still has a positive number of miles from his work to his new house. Okay? So you would just say, I mean, he may have moved over the entire distance to his work, which is totally possible, but it's still not a negative value for him to get to work. He doesn't have to go backwards. I don't know how you would want to say that. Regardless, he's still a certain number of positive miles away from his work. So that can't happen. And you can paraphrase that if you want to there. Just talk about why that doesn't work. Let's look at these your turn problems. The number of students in a chess club decreased from 18 to 12. What is the percent decrease? So we want to take our bigger minus smaller. 18 minus 12 is 6. And then we want to take our 6 and divide that by our original amount. The original amount in this one was 18. So we go 6 divided by not 41, but 18. And it looks like about 33%. So a 33%. And you should always put whether it's an increase or a decrease. I'm going to say decrease. Because the problem with percent change, just in general, is you don't know whether it's a positive or negative percent change using this strategy. Okay. Officer Brimberry wrote 16 traffic tickets or tickets for traffic violations last week, but this week he only wrote 10. What is the percent decrease? So we're going to go 16 minus 10, which is 6. And then 6 divided by the original amount, or last week's amount, 16. And we will get, okay, let's talk about that, I guess, 0.375. Turn it into a percent, so that's 37.5%. And how do I round that? Do I round it down to 37 or up to 38? I actually round it up to 38 because that 5 is, anything 5 or bigger means to round up. And again, that's a 38% decrease. Okay. Let's go ahead and take a look at using percent change. So given an amount and an original amount and percent increase or decrease, you can use the percent of change to find the new amount. It says here the grizzly bear population in Yellowstone National Park in 1970 was about 270. That makes that easier to remember. Over the next 35 years, it increased by about 115%. Okay, what was the population in 2005? So we want to find the amount of change. And in order to do that, we're going to take the 115% and multiply that by the original amount to find the amount of change. Okay. Now, we can't be multiplying 270 by 115. We do have to remember to rewrite that as a decimal. So 1.15 times 270, which is about 310.5 rounded up. Round to the nearest whole number is 311. So to find our new amount, we're going to take our original 270, add on the 311, and we get 581. So the population in 2005 was about 581 grizzly bears. Why would the percent change always be represented by a positive number? Okay, why would it always be represented by a positive number? It really comes down to the fact that the amount of change is always positive. Because we always take the bigger number in this form of doing this. We always take the bigger number minus the smaller number. So that's always going to be positive. Positive divided by a positive is always a positive. And that's what kind of gives us that idea. If an amount of $100 in a savings account increases by 10%, then increases by 10% again, is that the same as increasing by 20%? Let's look at it. If we take $100 and we increase it 10%, I don't really know what I'm trying to do there. I want to multiply that by 10% or 0.1. Okay. To shortcut that a little bit, that's $10. So my new amount, I add those two together, and I'm at $110. Now I want to increase that by 10% again. So let's take that 110, multiply it by 10%. That's $11. Okay, you can double check my math if you feel like it. When I add that to the 110 that I already had, that's $121. If I just take the the $100 and increase it by 20%, that's going to be $20. And when I add that to the original 100, I'll have $120. Okay, so it's not actually the same. Now I know that they're not too far off, but it's enough that when you scale this up or scale this down, it might matter even more. Okay, so no, they're not the same. That's important to know. That if you can get somebody to increase your money by a percentage multiple times, you're better off than a larger single percentage. Okay, this one here says a TV has an original price of $499. Find the new price after a given percent change. So let's say that something happens and maybe a sale ended, and we want to increase that price by 10%. What's that going to look like? Well, we're going to take our $499, multiply it by 10%. That's $49.90. And add that back to our $499 just to double check. If I take $499 times 0.1 plus $499, it's $548.9. So $548.90. This is something they didn't really talk about in this previous example, but dealing with a percent decrease. Basically, do it the same way. We figure out what 30% of that $499 is. So we're going to take $499 and multiply it by 0.3, which is 30%. And we're going to get $149.70, so $149.70. And to show a new amount of a percent decrease, we want to subtract that from the $499. Okay, we're trying to make the price go down, so we wouldn't add $499 to this. We want to take our $499 and subtract this. So let's go ahead and look at that. Let's take $499, subtract 149.7. I messed that up, I'm sorry. $499 minus 149.7. And so now it costs $349.30. $349.30. And there we go. I believe that's it. It is. So we need a code word for the day. Our code word for the day will be, let's go with original. I feel like that's very original. Your code word for the day, original. Get it right, get the points. Make sure you do the rest of the reflection. Have a great day, and we will see you in class.